In this video we're going to talk about normality. So normality is actually the number of equivalent weights dissolved in a liter of a solution. Normality is one way of expressing concentration in chemistry. So in this video we're going to learn about determining normality when you're given a molarity of a concentration. Of course we are already acquainted and we are already used to this molarity, a way of expressing the number of moles dissolved in a liter of a solution. So now when you're given molarity, how do you get to determine normality? Okay, so normality is going to be given as a product of molarity and N, where N is going to be the number of protons or number of hydroxide ions in a case of a base. In terms of an acid, it will be the number of protons or number of hydrogens present in that acid. Then another way of determining normality is dividing the number of equivalent weights by a liter of a solution. So we'll get to look at all these ways. So let's try to look at some of the examples on how to determine normality. So given that 0.1266 molar concentration of a sulfuric acid, H2SO4, how do you get to determine the normality in such a case? So remember, normality is given as a product of molarity multiplied by N, where N is either the number of protons or number of hydrogen ions in terms of an acid, or the number of hydroxide ions in terms of a base. In this case we have been given an acid, so the molarity has already been given to be 0.1266. So by now we know that molarity is moles per liter, so we have moles per liter multiplied by N. In this case our N is what? How many hydrogen ions are in this acid? So there are 2, so multiply by 2. So our normality is going to be 0.166 multiplied by 2. So our answer is going to be 0.2532. So the unit is going to be normality. So normality. Okay. Another example, we've been given 0.01 molar solution of sodium hydroxide. So for you to determine the normality, it's going to be equivalent to a product of 0.01 molar multiplied by how many hydroxide ions are present in this base. It's only 1, so multiply by 1. So in this case the normality is actually equivalent to what? To the molar concentration. So that's it when you're asked to determine normality when given the molar concentration. So now let's say you've been given the normality. How do you go about it? So I'll change something there. Let's say we've been given normality instead. How do you get to determine the molar concentration? Because there may be some stoichiometric calculations and titrations where they can give you normality, but you know in the actual sense for it to deal with a number of moles you're supposed to work with a molar concentration. So how do you convert a normality to molar concentration? So we already know that normality is given as a product of molar solution multiplied by N, where N represents the number of hydroxide ions or the number of hydrogen ions in terms of an acid. So therefore our molar concentration is given by normality divided by the number of what? Divided by the number of either protons or the number of hydroxide ions. So in this case it will be 0.01 divided by how many hydroxide ions do we have in this base? It's only 1. So the concentration will be 0.01 molar concentration. Okay, so that's it. That's the way to go about it. All you have to know is this formula. If you know this formula, depending on what they ask you to determine, you'll be able to use it. Okay, what is the normality in the 40 gram of H2SO4 in 10 liters of a solution? So in this case, they've given you the mass of a sulfuric acid. How do you get to determine the normality? So remember, we are able to determine normality as a product of molar concentration times what? The number of ions. Okay, so that formula, this formula is being used to determine what? Normality. Molar concentration multiplied by the number of protons or number of hydroxide ions in that what? Acid or base. So let's try to determine the molar concentration in this case. So we know that the molar concentration, M, is given by the number of moles in a liter of a solution. So how do you get to determine the number of moles? So when you're given the mass, so the number of moles is given by the mass divided by the molar mass. So the mass has been given to be 40 grams. Okay, so we're trying to divide by the molar mass of H2SO4. So we have H2SO4. What is the relative molecular mass? So hydrogen, we know it has got a molar mass of 1.008. Then if you get your periodic table, you try to check for sulfur. So what is the molar mass of sulfur? So sulfur, the molar mass of sulfur is 32.065, so we'll say plus 32.065, and we have got 4 oxygen atoms which are 15.994. So you have 2 multiplied by 1.008 plus 32.065 plus 4 by 15.994. So we have 98.0786 grams per mole. So this is our relative molecular mass of what? Of H2SO4, the given acid in this question. Let's have some space there. Okay, so we are dividing by 98.07. So of course grams per mole. Okay, so 40 divided by that, we have 0.4. So we have 0.4078 moles. So we've determined the number of moles. So let me just try to beat down there. So 0.04 moles. Okay, so we've determined the number of moles. So therefore our molar concentration is going to be the given number of moles that we've determined, 0.4078 divided by the liters of a solution, which in this case is 10 liters. So we have got moles per liter. And what we're going to have as our molarity is going to be, so we're dividing by 10, it will become 0.04. So I have 0.0408. Okay, so let me create some space aside. Okay, so we've determined our molarity, so that is molar concentration. So first, to determine the normality, we'll substitute in there. So 0.0408 multiplied by the number of hydrogen ions. In this case, if you look at the H2SO4, you see that there are 2. So multiply by 2, and our answer is going to be 0.08. So 0.082 normality. So that is our answer in terms of normality. So now, how can we use the other formula? How can we determine it using the other formula, where you are dividing the number of equivalent? So let's skip that answer that we've determined using this other formula, and let's try to work with our formula. Okay, so the other formula that you can use to determine normality is this: number of equivalent weights So number of equivalent weights divided by what? Liters of a solution. Okay, so we've already been given the number of the liters in the question. So how do you get to determine now the number of equivalent weights? We determine the number of equivalent weights of a proton. Okay, so we'll say 1 mole, since we're talking about an acid, we'll say 1 mole of a proton. We're trying to determine its mass. So we'll then multiply by, we have 1 mole of sulfuric acid, H2SO4, and per every 1 mole of the sulfuric acid that dissociates, we have got 2 moles of what? The hydrogen proton. So 2 mole of H plus. Okay. Then we also know that per every 1 mole of sulfuric acid, so you determine the molar mass of sulfuric acid, which we determine to be approximately 98. So it's 98. Per every 1 mole sulfuric acid is 98 grams. So say 98 grams per 1 mole. 1 mole H2SO4. Okay, so I've got 2. Okay. So we have got this cancelling out. So remain with grams there. So we can get a calculator and multiply. So we have 98 divided by 2. So approximately of 49 grams. Yeah, 49 grams. So 49 grams. Okay. So now, first to determine the number of equivalent weight, supposed to divide this mass that we've calculated. Okay. So the mass that we've calculated is actually the mass of a proton. So the equivalent, what do? So we're supposed to divide this 49 grams into the 40. Okay, so the 40 grams, the mass that is given, the mass of the acid divided by the mass of what? Okay. So 49 there. So you find that the 40 divided by 49, 40 divided by 49, we have 0.82. So let's have some space. So therefore we've determined the equivalent weight to be 0.82. We're supposed to divide by what? The liters. In this case we have 10 liters. So after dividing, you find that your answer is going to be 0.082 in normality, which matches up with the value that we calculated using the other formula. So 0.082. So units will be normality. So this matches up with what we calculated using the other formula, where we are saying normality is a product of molarity, and N, where N represents the number of protons or the number of hydroxide ions in a given base. Thank you very much for watching. I just hope this video gave you an understanding about normality, and you're able to do the interconversions between normality and molarity.